Let's look at number 4, asking a future value problem. So this is a grade 11 financial math. It's actually only specific to grade 11 math, and it's specific to the Ontario curriculum. So it's actually, I don't know if you learn this in the US curriculum. It might be in another course, like a financial math course. But in grade 11 Ontario curriculum, we have a unit with financial math and applications, and this is where this plays out here. So it's asking us, what is the future value? So what is the future value of, this is $800 1 year from today if interest rate, I misspelled interest rate is 7%. So what is the future value of $800 1 year from today if interest is 7%? So basically, if you were a grade 11 student approaching this problem, you would actually get an equation or an equation sheet, right? Where basically you know that basically all your equations. You know, compound interest, simple interest. You know, future value, present value, future annuities, and present annuities. So you have all these equations that you're given. I don't think you're expected to memorize these ones, just because it is kind of tedious in terms of memorize these equations. But what if through a formula sheet, what you would have gotten is that you would have gotten that this formula is FV for future value equals, it's the present value, so PV, or you can say principal amount, times, this is 1 plus R over M, where R here is the annual interest rate. M here is the number of periods based on compounding frequency. So it depends on how if it's compounded value here. So in this case, I think it's just 1 year, right? If the interest rate is 7%, because if it's bi-monthly or if it's weekly or something, that we would have to change this M value. And then we have M here again times T. T here would just be the time, right? So in this case, it's 1 year. So let's solve for this problem. FV, here's future value. So we're solving for future value. Our present value is 800, right? $800 is what we have now, right? We have $800 now. And we have 1 plus the rate, in this case, is 7%, right? 7%, we have to convert that to a decimal. So 7% is 0.007, right? 0.07 divided by M, which is the number of periods based on compounding frequency, right? So in this case, I'm assuming it's an annual interest rate of 7%. So there's only one compounding period. So in this case, it's only divided by 1 times M, which is also 1, times time, which is also 1, right? There's also, it's only from 1 year from today, right? So in this case, I can simplify this. This is 800. 1 plus 0.7 divided by 1 is simply just 0.7. And 1 times 1 here is 1, which is just to the power of 1 here. So basically, all I'm doing is just 800 times whatever 1.07 here. 800 times 1 plus 0.7, which is 800 times 1.07, which would equal my value in the future value would then equal $856 for this problem. So my future value is $856. So let's look at the problem here. So it's saying given principal amount is 800, that's good. Rate of interest is 7%. Time period is 1 year. We use this equation here, P1 plus R to the power of T. I don't like how they did not include the M here. Like, it is implied that it's the compounding period is 1, but if, for example, if it was 7% like biannually or monthly example, then this equation changes. So I actually don't like the equation that they're using here, but it still gave us our correct answer of 856, and they subbed in everything correctly, I believe. They just divided by 100. Let me see. P is the principal amount invested, R is the rate of interest, and T is a time period in years. And they did 1 plus 7% here, which is 0.07. So this here still gave us a correct answer. So I'm going to say good solution. However, I'm going to copy and paste this formula. However, this formula, the formula does not account for number of compounding periods if interest rate was monthly or bi-weekly, for example. a better formula to use would have been, and my formula is FV equals PV times 1 plus R over M to the power of MT, right? Where M it equals basically the number of compounding periods, the number of compounding periods. Sweet, so solution here is correct. I just didn't like their formula that they used, but it's okay. Solution here is correct.